Good day everyone. I am Clarence Tapang from BSAT 31 and this is my video discussion regarding some topics or questions regarding our module number 2, which is the standard atmosphere. So number 1, why is it necessary to set the standard altitude? Setting a standard altitude reference in aviation within the context of the standard atmosphere is necessary for several important reasons. Standard altitudes are crucial for maintaining safe separation between aircraft, especially in controlled airspace. The use of standard altitudes help prevent mid-air collisions by assigning specific altitudes to different flights, ensuring vertical separations. Furthermore, standard altitudes are essential for navigation and flight planning because they can be the reference points for route planning, obstacle clearance calculations, and the creation of aviation charts and maps. In addition, standard altitudes are used in conjunction with altimeters to provide accurate altitude readings. Pilots set their altimeters to a standard pressure setting at higher altitudes. This ensures that their altitude readings are consistent and can be easily compared with other aircraft. Moreover, they serve as a reference point for determining aircraft performance under specific atmospheric conditions. In summary, setting a standard altitude reference within the standard atmosphere is fundamental to aviation safety, efficiency, and communication. It ensures that all aviation stakeholders can operate within a common framework, reducing the risk of accidents and enhancing the overall effectiveness of air traffic management and flight operations. Number 2, what is the different types of altitudes? We have 6 types of altitudes. We have geometric altitude, absolute altitude, geopotential altitude, pressure altitude, density altitude, and temperature altitude. When you talk about geometric altitude, it refers to the actual altitude measured from the sea level or from the ground. Geometric altitude is used primarily in aviation for navigation and obstacle clearance, while absolute altitude is the distance or altitude measured from the center of the Earth. Then the geopotential altitude, it is referred to as the fictitious altitude because this altitude is where we assume that there is no change in terms of your gravitational acceleration, whereas gravitational acceleration varies in terms of altitude. Kaya ito nasasabi na fictitious altitude because there is no change in terms of your gravitational acceleration kahit na yung gravitational acceleration ay nagva-vary in terms of altitude. So dahil dito, it can be considered a gravity-adjusted height. Pressure altitude is responding to ambient pressure. Pressure altitude is useful for calculating aircraft performance and determining altitude above sea level. Density altitude corresponds naman to your ambient density or actual density. Actual density of air in that particular altitude. It is used to determine aircraft performance, particularly engine power and aerodynamic performance. Pilots use density altitude to assess aircraft capabilities in non-standard atmospheric conditions. While the temperature altitude, it corresponds to ambient or actual temperature. It may refer to the altitude at which a specific temperature is found in the atmosphere, which can vary with changing atmospheric conditions. This last 3 altitude, it is related pagdating doon sa operation of aircraft or how we should fly an airplane. Because for every altitude, nagva-vary yung mga properties of air, which is yung pressure, density, and temperature. These altitudes are essential for flight planning, navigation, and ensuring safe flight operations. Each type of altitude provides specific information about an aircraft's position or the atmospheric conditions that can affect its performance. Pilots, air traffic controllers, and even meteorologists use these altitudes to make critical decisions and maintain the safety and efficiency of aviation operations. So let us move on sa number 3. Is it possible that geopotential altitudes is equal or same in terms of value with geometric altitudes? So the answer is no. It's not possible because there is a little difference for geopotential altitude and geometric altitude even at low altitudes. So it is about 0.1 out of 1% difference or to be exact is 0.001. So only at altitudes above 65 km does the difference exceed at 1%. So kahit katiting lang yung difference, meron pa rin. Kaya in terms of value, it is not possible that geopotential altitudes and geometric altitudes is equal or the same. Then number 4, describe the relationship of the properties of air whenever the altitude changes. So before anything else, we consider two regions of atmosphere. It is different from layers of the atmosphere. So magkaiba po yung regions at layers of the atmosphere. So sa two regions of atmosphere, which is the gradient and isothermal region. Gradient region are regions with a varying value of temperature, while isothermal regions are those with constant values of temperatures. The troposphere extends from 0 to 11 km, and this is the gradient region, and the stratosphere goes from 11 to 25 km. So, dito naman yung isothermal region. Mahalaga ito malaman kasi ang temperature is one of the properties of air. So, what is the rest? Which is the density and pressure. Now, the relationship of the properties of air to altitude is that it is inversely proportional to the altitude. So, kapag tumaas yung altitude, bababa naman yung pressure. So, ayun, inversely proportional doon. Except when in the isothermal region, because sa isothermal region, it is where the temperature is constant. Kaya, ayun yung relationship ng properties of air, yung pressure, density, and temperature. It is inversely proportional to the altitude. Number 5, derive and interpret the hydrostatic equation. When we talk about hydrostatic equation, it refers to the relationship of pressure to the altitude or height. In terms of hydrostatic equation, we assume that there is a state of equilibrium because we are analyzing a fluid such as an air at rest. Be reminded that all forces that are upward are positive and the downward forces are negative. To understand hydrostatic equation, let us look at this figure. Consider a stationary fluid element of air at rest shown at the figure. For convenience, we use rectangular faces whose top and bottom sides has a length and width of 1 unit and whose sides have a length of infinitesimally small or immeasurably small height, which is labeled as DHG. We have force on top, bottom, and also force from the weight of the air. So, be mindful that pressure is equal to force per unit area. So, if you derive it, we can say that force is the product of pressure and area. So, sa figure, hanapin natin yung force ng top, bottom, and weight ng box. So, kapag in-apply natin siya sa top surface at bottom surface, ang force sa top surface ay magiging negative P plus dP times 1 times 1. At ang force naman sa bottom ay positive P times 1 times 1. So, kaya negative yung sa top force ay dahil pag downward forces, negative, at upward forces ay positive. Ngayon naman, let us recall the idea of weight. If we talk about weight, the force is equal to mass times acceleration. And mass is equal to density times volume. Therefore, our force will be equal to the mass, which is yung density times volume. Whereas, yung volume natin ay ang 1 times 1 times dHg na nandun sa figure. And the acceleration that we will consider would be the pull of gravity or the gravity or yung G. So, the force or the weight of the air is equal to negative P G dHg or the negative density times gravity times the volume. It is negative because when we talk about gravity, it refers to a downward force or downward or the pull of gravity. So, we have the force ng bottom, top, and force due to local acceleration of gravity or the weight of the air. So, balikan natin na kapag pinag-uusapan ang hydrostatic equation, we assume that there is a state of equilibrium. So, when we talk about equilibrium, the summation of the forces is equal to 0. So, transforming this algebraically, we all have the equation negative dP is equal to Pg dHg, and this is the hydrostatic equation. Number 1 sa ating sample problem, calculate the standard atmosphere values of temperature, pressure, and density at a geopotential altitude of 14 km. Okay, so hanapin muna natin yung ating temperature. So, okay, hanapin muna natin ang ating temperature at 11 km. Dahil constant lang siya, ang ating working equation ay T is equal to T sub O or temperature at sea level plus lapse rate or alpha times H minus H sub O or altitude at sea level. Dahil at sea level lang siya, so 0 kilometers lang siya, pwede natin siyang ma-cancel out. Okay? So, operahin na natin yan. So, ang ating working equation na ay ito. Then, ano na lang ba yung hindi sa atin given dyan? Which is, syempre, yung temperature. Dahil ang ating temperature at sea level ay 288.16 Kelvin plus yung lapse rate natin na negative 6.5 Kelvin per kilometers times 11 km. So, kapag plinat lang natin yan sa ating calculator, ang ating temperature ay 216.66 Kelvin at 11 km. So, ayan ang ating temperature. Ngayon, alam na natin yung temperature natin na 216.66 Kelvin. Hanapin naman natin yung ating pressure at 14 km. Okay? Dahil 11 km to 25 km siya nagre-range, ang ating gagamitin na formula ay for isothermal region. So, isothermal region. So, ang ating working formula ay magiging P over P sub 11 is equal to times gravity over gas constant, temperature. Okay? So, ano na lang given na ano na lang yung kulang natin na given dyan, which is yung pressure. Okay? Dahil yung P sub 11 natin ay constant din siya na 606.82 Pascal. Okay, so i-derive lang natin yung formula para makuha natin yung P. P sub 11 times to VO over RT H minus H11. Okay. So, dahil dyan, napunta tayo dito sa equation na to, ipa-plot lang natin or magbe-basic substitution lang tayo. So, babaan lang natin yung size natin para maliit. Okay. Ngayon, substitute lang natin. P sub 11 ay magiging 22,606.82 Pascal times E. Yung ating negative GO ay negative 9.81 meter per second square dahil ayun yung ating gravity. Ang gas constant natin na R ay equivalent sa 287.08 joules per kilogram Kelvin. I-multiply siya sa temperature natin which is 216.66 Kelvin. All over na i-multiply natin siya sa ating altitude which is yung 14 km or 14,000 meters. Bakit meters? Kasi kapag ginawa natin km yan, mamamali yung ating value. Minus 11,000 meters. So, kapag plinat lang siya sa calculator, ang ating magiging value ay ang ating magiging pressure is equal to 14,084.73 Pascal. So, ayan yung ating pressure. Ngayong alam na natin ang temperature at pressure, alamin naman na natin yung density. So, yung density, same lang din siya sa pressure at isothermal region yung gagamitin natin yung formula. Kaya yung working equation natin ay density over density sub 11 is equal to E times negative GO over constant temperature times H minus H11. Yan. So, i-derive lang natin siya. Magiging negative to. Dahil yung ating density sub 11, yung constant na value niya ay 0.364 kilograms per meter cube. Okay? So, i-plot lang ulit natin. I-substitute lang natin. Basic substitution lang. Magiging density is equal to 0.364 gram per meter cube. E. Tapos ayun, 9.81 meter per second squared times 287.08 na gas constant. Yung temperature natin, multiply lang sa 14,000 meters minus, sorry, hindi na kasya, dito na lang 11,000 meter. Pag plinat lang natin siya sa ating calculator, ang ating magiging value ay for density na nasa 14 km ay 0.227 kilogram per meter cube. Okay? So, ayan. Dahil alam na natin yung therefore ang ating temperature, pressure at density, ang value niya sa at 14 ang value nila sa 14 kilometers in the atmosphere is given by this following result. Sa T natin is equal sa 216.66 Kelvin. Ang ating pressure natin at 14 is equal to 14,084.73 Pascal. At ang density natin sa 14 km ay 0.227 kilograms per meter cube. So, ayan ang ating final answer. If an airplane Number 2, if an airplane is flying at an altitude where the actual pressure and temperature are 4.72 times 10 raised to 4 Pascal and 255.7 Kelvin respectively, what are the pressure, temperature, and density altitudes? So, we can calculate the pressure altitudes directly by calculating the height where such particular conditions of pressure exist. Since the temperature is given as 255.7 Kelvin, which is in between the sea level value and the value for 11 km, that is 216.66 Kelvin. Therefore, for gradient layer conditions, yung ating gagamitin. So, we have na pressure over and 1 plus alpha altitude over T sub O. 5.26. Dito natin para mas kita. Yan. Okay. Sa given na lahat ng ating mga variables dito except lang sa ating altitude, at ito ang nag-i-indicate na siya ay ang ating pressure altitude. Okay? So, basic substitution lang tayo. Ang ating P ay 4.72 times 1072 raised to 4 Pascal, which is given, over pressure natin at sea level na constant na 101 325 Pascal is equal to 1 plus yung lapse rate natin na 0.0065 Kelvin over meter, tapos yung altitude all over yung temperature natin at sea level, which is 288.16 Kelvin, all i-raise natin sa 5.26. So, kapag plunat lang din yan sa calcu, ang lalabas na sagot ay 5,992.91 meters, which is ayun na yung pressure altitude natin. Pwede rin natin ma-convert na 6 km. Okay? For temperature altitude naman, okay, so sulat lang natin dito sa taas na yung ang ating pressure altitude ay 6 km. Okay? So, hanapin naman natin yung ating temperature altitude naman. No? Ang ating working equation naman ay T is equal to T sub O plus alpha times H minus HO. So, dahil nga pwede natin ito ma-cancel out, pwede na natin yan mabura dahil ang H sub O ay 0. Okay? So, ayun, tulad din kanina sa pressure, plot lang natin ang ating mga given. So, yung temperature natin ay 255.7 Kelvin na makikita sa given sa question. At ang T sub O, which is yung temperature natin at sea level, plus yung lapse rate natin, which is negative 0.0065 Kelvin over meter times H. So kapag plinat na rin natin yan sa ating calcu, ang lalabas na value ay 4,993.85 meters, or pwede natin i-convert to 5 km. So ang ating temperature altitude ay 5 km. So ano naman ang ating density? For density altitude, we must first get the density, which conforms to the value for pressure and temperature at a particular point in the atmosphere. Therefore, yung equation natin ay makukuha natin sa dito. Okay? Which is yung kapag dinerive natin siya, magiging density or pressure all over gas constant times temperature. Okay? So, plot lang natin yung ating mga given dyan. Siyempre, yung pressure natin na 4.72 times 10 raised to 4 Pascal all over yung gas constant natin, which is 287.08 joules per kilogram Kelvin, multiplied sa ating temperature, which is 255.7 Kelvin. Kaya ang ating density ay 0.643 kilogram per meter cube. Okay, so ayun, may density na tayo. Kaya gamitin na natin siya, ay mapaplat na natin siya sa working equation natin for gradient region na density over density sub 0 is equal to 1 plus lapse rate altitude over T sub O. Okay? So, ayan yung working equation natin for density, at ipaplat lang natin ang ating mga given. So, basic substitution lang ulit. So, yung P na 0.643 kilogram per meter cube over 1.225 kg, given na yan, constant, is equal to 1 plus yung lapse rate natin, negative 0.0065 over, mali, 65 Kelvin over meter times yung altitude over temperature, raise natin sa 4.26. So kapag plinat lang ulit yan sa ating calculator, ang lalabas naman ay 6,224.83 meters, na pwede natin siyang convert to 6.22 km. So ang ating density altitude ay 6.22 km. Okay? So ang ating final answer ay, for pressure, meron tayong 6 km. For temperature, meron tayong 5 km. At sa density, meron tayong 6.22 km.